So in Gaussian Jordan, we're going to want to have, in the end, our augmented matrix have an identity matrix here, and then you'll have A, B, and C, or X, Y, and Z. Those will be your answers in the end. A little review. In Gaussian elimination, we just tried to get this bottom corner to be zeros first. Gaussian Jordan, you still start with that. You start the same way as Gaussian. You get that bottom triangle of zeros first. But then you also want to systematically get those top values to be 0 as well. So I would like you to try to get this one into that form. Zeros in all the corners and ones everywhere else for this matrix. We are going to start, and I'll talk about some strategies that you can use to solve this. So first of all, what you want in the end, is the identity matrix on the right. Now I'm going to label, if possible, the first thing I want to get is this to be a 1. If that's easy, this is not a necessity, but if you can make that a 1, that makes your life a lot easier. So when I look at these equations, I notice that there's a 1 in front of this one, so I might even just write out my equations that way, that that one's in the top as opposed to the other ones. The second thing, Gaussian elimination, we got this second and this 0 third. That's the same as Gaussian elimination. We're going to do the same thing. You need to get the first column of zeros first, and then we're going to get this 0 as well. Once you've done that, this is easy to make a 1. So in the same way that we wanted to get a 1 in the top left-hand corner, after we get the zeros, we want to get a 1 in the bottom right-hand corner, because that will allow us to do the same thing working upwards. We're going to want to get this column of zeros next, and then this a 0, right? You might even, once you get that column of zeros, you might even make this a 1 at step 5.5. I don't know if you call it 6 and the last one 7, but we'll see how that works. So when setting up my matrix now, I decided 1, -2, -1, 2, 2, -1, 2, 10, and 4, 1, 1, 5. Step 1, the purple, done. I got a 1 in the top left-hand corner, and I didn't have to have any decimals or fractions. Perfect. Now I can make these zeros. I can make row 2 a 0 by making row 2 equal to row 2 minus 2 row 1s. And I could make row 3, so this is something you are allowed to do 2 in one step if you like. I can make row 3 equal to row 3 minus 4 row 1s. So having that 1 in that top corner will allow us to get zeros easier. Notice I'm not changing row 1, so I rewrite it 1, -2, -1, 5. Row 2 is row 2 minus 2 row 1s. That gets us a 0 there. -1 minus a -2 is -1 plus 4, and 2 minus a -2, 4, 10 minus 4, 6. Row 3 is row 3 minus 4 row 1s. That gets me a 0 here. 1 minus a 4 times -2 will be 1 plus 8, which will be 9. 1 plus 4, which will be 5. And 5 minus 8, -3. Okay? Next, I want to get this to be a 0. I can make row 3 equal to row 3 minus 3 row 2s. Row 1 doesn't change. Row 2 doesn't change. And now row 3, this will still be a 0 because 0 minus 0 will still be a 0. 9 minus 9 will be 0. 5 minus 12 will be negative 7. And negative 3 minus 18, negative 21. Which number? This 5? What's wrong with it? Oh, it should be a 2. See? Good eye.
No, it's over here.
But it should be a 5 here, though. I just changed. It should be a 5 right at the beginning. No, it should be a 2. Oh, I cheated and see? Oh, wow. Okay. Yes, it was a 2, and it just miraculously became a 5. And we would have ran into problems. Oh, I want the small eraser. 2. There we go. Now we can make that row 3 in the bottom right-hand corner a 1, because we can take row 3 and divide it by negative 7. If we do that, wow, this is a skinny matrix. We're going to get 3 here, 1, 0, 0. All of the other ones stay the same. And 1, negative 2, negative 1, and 2. Funny that the mistake that I made was on the one line that supposedly didn't change, and I changed something. Now that we've got that 1 in the bottom right-hand corner, it's going to be easy to move upwards and get the zeros above. So what I can do is I can say row 2 is going to equal row 2 minus 4 row 3s, and row 1 is going to equal row 1 plus row 3. Row 3 doesn't change. Row 2, what changes is I'm going to take row 2 minus, this will still be a 3. 4 minus this will become a 0. And now we'll have 6 minus 12. No, 6. Yeah. 6 minus 12, negative 6. And row 1 plus row 3, this will still be a 1. This will still be a negative 2. This will become a 0. And when I add them together, I get 5. At this point, can you see that it'll be easy to make this a 1 in between? So row 2 can equal row 2 divided by 3. 0, 0, 1, 3. 0, 1, 0, negative 2. And we still have 1, negative 2, 0, and 5. And finally, we can now get that last 0. We can make row 1 equal to row 1 plus 2 row 2s. These ones don't change. And now adding them, I'm going to get 1, 0, 0, negative 4 plus 5, 1. So we know that x equals 1, y equals negative 2, and z is equal to 3. Thinking about it, if we look back, now that we've gone through it, and now I have the steps here, do the steps sort of make sense? We can get zeros easily with the 1, but we need both of these zeros here in step 2 in order for us to be able to get a 0 in step 3. And then once we got zeros in the bottom corner, it's going to be easy to get that 1 in the bottom right-hand corner, which makes the zeros in the column above easy to get. And we just sort of keep doing the same process until we've figured it all out. Now, the reason I got you to try it on your own first, one, is to recognize how easy it is to make mental math errors. It's not hard math, but you have to concentrate on every step, right? You saw up here, I took one little thought away. Did you see why I wrote the 5? I was like, oh, I'm not changing row 1, and I took this old row 1 and took that 5 from there. All right, try this one. Ever done? Ever. Okay. So I'm going to make this row 1, this row 2, this row 3. Or did most people do it the other way? I know almost everybody had this one as row 1. Did most people have it 3 as row 2? Yeah. Yeah? Okay, I'll do that. Check this out. Oh yeah. There we go. And so we've got 3, 4, 1, -1, and 2, 4, -3, 9. Perfect. So now I can change row 2 to equal row 2 minus 3 row 1s, and row 3 to equal row 3 minus 2 row 1s. Row 1 doesn't change. 1, -4, -2, 12. 0 and 0 will get there. Row 2 minus 3 row 1s, so -8. And minus 3 row 1s, do you get 7? Okay. And row 2 minus 36, -37. And row 3 minus 2 row 1s will give me 0. Minus, oh, wait for it, this is 16. Oh, I heard mumblings out there. There was mumblings. 7, there we go. 6, 7, -37. Row 3, so this will be 8, this will be 12. Yes. And this will be 4 plus -3 will be +1. And 9 minus 24. -15. Did everybody get to this step? Yes. And then this is where things felt bad because of the 16 and the 12. So a couple of different options we could do here. The longest option everything is good, right? Up till now? Yeah. Okay. So what we have right now is we need to make this one a 0. And we have an issue that the 16 and the 12 are not nice numbers to work together. Yes?
The R2 minus 3R1, the -1 minus the 3. Oh, wait. Sorry, never mind.
That's good?
Yeah, never mind.
All right.
I did it wrong.
So we have this 12 and this 16, and we get an idea sort of a lowest common multiple that's going to help us. Here, I can get 48 by doing 3 times 16, and I can get 48 by doing 4 times 12. Right? So sometimes it might help to change them, or you can do it all at once, and I'm going to make row 3 equal to, and I'm going to take 4 row 3s and subtract 3 row 2s. Why would I do that? Because that's going to give me 48 here and 48 there. And when I subtract, it's going to be equal to 0. So if I do that, row 1 doesn't change. Row 2 doesn't change. Row 3 now becomes 0, 0. Now, 4 row 3s, that'll make this a 4 minus 21, negative 17. And 4 row 3s, this would make this negative 60, minus 3 times 37, 111. Right? 60 minus 111 leaves me with negative 60 plus 111 will be positive 51.
I don't like this. I really don't.
And then row 3 is now equal to row 3 divided by a negative 17, 0, 0, 1, negative 3, 0, 16, 7, negative 37, 1, negative 4, negative 2, and 12. And now we've successfully got that 1 in the bottom right-hand corner. Now I can get these next column of zeros. So I'm going to change row 1 to equal row 1 plus 2 row 3s. And I'm going to change row 2 to equal row 2 minus 7 row 3s. 0, 0, 1, negative 3. That doesn't change. And now I'm going to get 0, 16, 0. Row 2 minus 7, so that would be negative 37 plus 21. Negative 16. And 1, negative 4, 0. Row 1 plus 2 row 3s. That'll be a 6. I can now make row 2 divided by 16, 0, 0, 1, negative 3. That doesn't change. Top one doesn't change. And we now got a 1 in the middle. Finally, we just need to make row 1 equal to row 1 plus 4 row 2s. And that will make this, that's already 1. 0, 0, and adding 4 of those, positive 2. Done. Okay. So the next step, same kind of thing, but now it's in a word problem. So you have to read the word problem to create the equations, and then use the equations to create your matrix and break it down. Just because we've only done 2 questions so far in 50 minutes? But how long did they take me to do? Like, it wasn't too long.
Like you already knew exactly what to do. We have to think.
Oh, I apologize for making you think.
No, it's not.